Okay, let's get the party started on problem number 10. This is asking us to do a lot of information on graphing of logs. And so there's a few different ways you can process this. Some people need to rewrite it back in exponential form. That helps them see how the problem works. Some can process it with the transformation rules. And so at the end of the day, I'm just going to go in the order that they asked us the question, and we can kind of elaborate along the way. So you can figure out the domain algebraically. Algebraically, we know that this particular log functions have restrictions, and so you can set your domain to be x is greater than 0 because it can't have a 0 or a negative inside a log. And so then, of course, you can graph this on a number line if that helps you. 0. So ultimately my domain for this function is going to be 0 to infinity. That means it's going to get really close to the x equaling 0 but never be 0. Okay, so if we want to go ahead and go down to the sketch, I can show you what that will look like. Here is my graph. Here is x equals 0. This will be my vertical asymptote, which does answer my last question. X equals 0 is my vertical asymptote, and so that means it'll start at 0 and go to infinity. We'll figure out what it looks like as we move on. So let's talk about x-intercepts. Okay, x-intercepts means that it has 0 for a y value, and so I can say 0 equals log base 7 of x, and so this one does help if you rewrite it in exponential form. This would say 7 to the 0 power is x, and so 7 to the 0 power is just 1 equals x, so my key point would be 1 comma 0, and we know that to be true of all log parent functions. And so here we have a key point at 1, 0 right here, and so we have a vertical asymptote. Of course, if you needed more points, you could always play around with this. You could say, okay, well, what if x was 1, what if x was 2, and so forth. And so this one, in fact, it may even work better if you do just put it in your graphing calculator and you get your graph, and so you get something that looks like this. Again, if you want to do your table, some people find it to be easier if you think about it in logarithmic form and you, in fact, play around with y's. Your inputs would be your y value instead. So let me show you what I mean. So if I kept it where I then put a y value of 1, that would be 1 equals log base 7 of x, which would be 7 to the 1 power would be x, and 7 to the 1 power is just 7. So then y, the x value would be 7, so 7, 1 would be somewhere way down here, and you'd have 7, 1, and so forth. If you wanted to do something smaller, you get the idea. So you can always play around with it by rewriting in an exponential form and have an input-output. And so if not, you can put it in your calculator, log base 7 of x, and hit the table. If you have an older calculator, you may have to use the change of base formula, and so that would be, you'd go y equals log of x over log of 7, and then you'd hit enter and it could graph your image for you. Okay, let's take a look at B. B, very similar, however, the implied base here would be 10. We also have some transformation rules going on here, and so we'll get to that. Let's start first with our domain. Domain is set the inside of your log x plus 5 to be greater than 0. X would have to be greater than negative 5. You can see that that would be from 5 to infinity. And so if this helps you, you know your graph would 1, 2, 3, 4, 5. Negative 5 would be our vertical asymptote at x equals negative 5. Make sure you write it as an equation. X equals negative 5 is my vertical asymptote. So now we just need to figure out what is our x-intercept, and we'll talk about our key point transferring and all that other stuff. In fact, I kind of want to do that first before we get to the x-intercept, because it's kind of, this question on this particular problem is a little kind of silly, and we'll talk about why. So here we come up here to our graph. We see the plus 5 on the inside. That affects your x values, and so that's going to make it shift to the left 5 units. The 4 is a positive, so that's going to make it go up 4. And the negative makes it reflect over, which axis is that? That's right, the x-axis. Okay. And so we do have our key point. It's the key point that we help to see here. 1, 0 would now shift over 5. So 1, 2, 3, 4, 5. And it would go up 4 units. Up 4. And so then we have the reflection piece. And so now it would look like something like that. Let's talk about this x-intercept for a minute. So x-intercept implies that your y is 0. So I had a 4 minus log x plus 5. And so I would move my 4 over to the other side. So it'd be negative 4 equals negative log base x plus 5. I divide both sides by the negative 1. So that'd be 4 equals log base 10 of x plus 5. And now to solve for x, you'd want to rewrite it in exponential form. So then we would have 10 to the 4th power equals x plus 5. And now I would subtract 5. So 10 to the 4th minus 5 equals x. 10 to the 4th power is a very large number. It's 10,000. So 10,000 minus 5 would give me an x value of 9,995 equals x when my y is 0. So the ordered pair would actually be 9995, comma 0, and that's just not really a practical x-intercept, but I mean, clearly you could see the trend. It would eventually cross somewhere way over here at 9,995. Hope this helps. If you needed to put this in the calculator, and it should be really easy since it has a base of 10, so you should be able to put it in just like this. Get your table, get your image. Only thing is it would be very difficult to find your x-intercept. You'd have to scroll in your positive spectrum for quite a while. Hope this helps.